Okay, so I am recording now. Let's look at the answer. I didn't give you a whole bunch of time for this, but um, I just wanted to see if anybody could or could remember this, maybe not. And just for the YouTube people, because I didn't hit record right at the beginning, we are looking at intravenous flow rates. We're basically applying everything we've did or you guys did in Math 1700 and Chapter 1, like unit conversions to kind of real life pharmaceutical type of problems. The other thing I'll mention for the YouTube people that I mentioned a few minutes ago is there is an assignment coming today, which you will have the whole weekend to do. So until Sunday. To do chapter 2. And the reason there's an assignment is, and I haven't mentioned this yet, is we need to have our first test, which is going to come up next week. We'll talk about the test at the end of the class. We'll try and pick a day that works for everybody. It will be on units 1 and 2. And I have sample tests and I have sample assignments with answers that you guys can use to study. So don't worry, we're not doing a test today or tomorrow, but sometime next week we do have to have the first one. So I want to get this assignment finished by the weekend. It'll be a pretty easy assignment as well because this chapter wasn't too bad. If you guys can remember, it's basically unit conversions. So how does this one work? Well, first thing, let's read the question together and I'll outline some of the important information. This one's actually a good warm-up one because question A, pretty easy. Question B, a little bit more difficult. Okay, a solution for intravenous infusion. So remember how this works. Somebody has a bag of solution hooked up to them through a drip kind of situation into their bloodstream. And this infusion contains, so the solution, what we would call in chemistry, is 0.025 micrograms per milliliter. So every milliliter of solution has 0.025 micrograms of the drug, whatever it is. We need to figure out how many drops per minute this should be set up to be if, say, the doctor said this person needs 2 micrograms per hour. And the infusion set itself can deliver 25 drops per minute. Okay, so first things first, we know, and I'm going to kind of set this one up, I guess. Oh, hold on. It's been so long, I forgot I had to do this. Most of you guys have had me before. You know I usually use PowerPoint, so even like this takes me a minute. Is this going to work? Yes. Okay. So I know that there's 0.025 micrograms in 1 milliliter of this drug. I know that what we need to administer is 2 micrograms per hour. And I also know that the infusion set, the set itself can deliver 25 drops per minute. Drops equals 1 minute. Okay, so we're trying to figure out, we're going to do these conversions so we can get to drops per minute. So, okay, I'm going to do this slightly different than the solutions say. And what I mean is I'm going to start here. 2 micrograms per 1 hour is what we're needing to deliver. And sorry, my mu's, right? It looks like an M. That's a micro or mu, right? I'm not the best at drawing that, but that little squiggly M here, that means micro. Okay, I also know that in my solution, and well, one thing I could do is change just the minutes right away, but I'll save that for a second. I know that my solution is 1 milliliter will deliver 0.025 micrograms. Okay, So we're working our way through this. We're trying to get at the end drops per minute. So we're trying to convert micrograms to drops and hours to minutes. So converting the micrograms to drops is pretty easy. And actually, let me even go back here. Okay, I want to convert micrograms into drops. Well, I know that 2 micrograms can be converted into milliliters because 1 milliliter will deliver 0.025 micrograms. Okay, now I need to convert the milliliters to drops. Well, I also know that 25 drops. Oh, this should be milliliters here. Sorry. There's 25 drops in 1 milliliter. This is milliliters here. Sorry about I said minute. It's milliliters. So my milliliters cancel. So now this calculation right here, I've converted micrograms to milliliters, and I've converted milliliters to drops. So I know how many drops I need to give per hour, and there's only one step left. I want to see how many drops per minute. Well, I already know how to convert hours to minutes. 1 hour is 60 minutes. So I'm going to multiply this by 1 hour over 60 minutes. So, oops, my hours will cancel, and that's it. I get 33 drops per minute. Now, my calculator actually says 33.3 drops. So if you were doing this on an assignment and you said 33 or 34, I would give you the mark, because you can't administer a third of a drop. And actually, if this is 33.3, you might want to say 34 drops a minute. So if this said 33.3, you could say 34 drops per minute. Either way, you would get the mark. Now, I know it's been a long time. Some of you just remember, this is a little different than just math, because some of you guys in a math question might be tempted, oh, well, 33.3, we round down, which is in math. Yes, we do. But remember, we're delivering medicine here, and you can't deliver 33.3. So our options are 33 drops a minute or 34. And I guess to give the complete medication, it would be 34. If you look at the answer key to this, it does say 33, which I would also take. I'm not that picky. But just remember, if we're trying to deliver medicine, you typically would round up. Not by too much, right? Just like 34. Okay, let's do another one. If that made no sense to you, I'll do another one. I know it's early, and it's been a long, this is like one of the longest breaks we've had, or I've had, because they extended Eid. So just take a breath. If that didn't make any sense, let's do another one. Question B. 0.2 milligrams of a drug is dissolved in 0.5 liters of solution. That's my concentration. So I know that in 0.5 milliliters, we have 0.2 milligrams. Okay, so 0.2 milligrams would be in 0.5 liters of this solution. The solution needs to be infused at a rate of 20 micrograms. So 20 micrograms we need in 1 hour. The set will deliver 15 drops per milliliter. So what should we set the flow rate at? Again, and you guys will always be looking for drops per minute. I don't think there's, no, that's it. Yeah. So, wink, wink, if you ever had to do this again on an assignment or something, it would always be drops per minute. So using this information, oops, it's actually the same as the last question. However, there's one catch here, at least one bit of extra work. We need to change, what was it? Well, the micrograms and milligrams we need to consider, or we need to be able to change. Okay, so you don't need to do it if you have no idea, that's okay, but I'll give you a minute to just try this one. The answer, I think, is 13 drops per minute. Let's just see if you can do this one, and I will be back. I do feel bad. I want to let you guys do this one, and I probably should shut up and not say anything, but I just want to give you a little hint because it has been a long time. The big trick here is that I do need to convert from milligrams and micrograms. I need to make that conversion. And I'll just give you this for now. I'll show you guys where this comes from. But 1 milligram is equal to 1,000 micrograms. I'm sorry. It's not, I'm not sick. I haven't talked to anybody in like 10 days, so my voice isn't as good. This is needed to do this question. This is a constant. It's going to be given to you on any on tests or assignments. We did this back in chapter 1. You do need this for this question. If anybody doesn't know where this comes from, I will show you, but I just like to see in a minute or two if anybody can get 13. So I'll be back in 2 minutes. Guys are pretty quiet today in the chat, but that's all right. I'm feeling pretty quiet myself. Like I said, it's been a pretty long and relaxing break, but keep working. And in the chat, let me know, is there questions? Does anybody need more time? Did anybody get 13 or did somebody get a different answer? Let me know you're alive and we'll look at the answer in a minute. Okay, let's have a look. All right. So, okay, so this question, we're again, all of these fluid rates are the same thing. Like, there's no like set formula for this, or not really. R- Basically, what we're doing is we're trying to convert all of our units into drops per minute. So, I have a milligrams per liter. I have micrograms per hour, and I need basically any size like milligrams, micrograms, or even liters. Sorry, not liters, milligrams or micrograms. We're going to try to convert to drops. And then we're going to try to convert that into minutes, drops per minute. So all of our sizes are micrograms, milligrams, all of those, we're going to try to convert into drops. And then when we know the drops, we convert the time into minutes. You'll see, I hope you see, and like there's lots of practice here for you guys to check out. So let's look at this one. Oh, and again, there is a unit conversion back from chapter 1 in here, and I'll show you guys how to do that just as a reminder before we move on to the next and final part of chapter 2. Excuse me. The final part of chapter 2 is actually quite easy. I think so anyways. So, okay. First things first, let's read the question. 0.2 milligrams of a drug is dissolved in a solution, 0.5 liters. So this is the concentration in the bag, the strength of the solution that we're delivering. The prescription says that the solution has to be infused or given to the patient at a rate of 20 micrograms per hour. So there is a small issue here. We have milligrams and then it's micrograms as a rate. The infusion set itself, every 15 drops will be 1 milliliter of solution. So how many drops per minute do we set this up? This is actually something I've done in school, but I did this a little differently. If you guys can remember in your chemistry titrations, you can set up a titration to be drops per minute, and then you can graph that information. So this is stuff that I've done as well in chemistry. So for me, this is like a chemistry question. For you guys, this is like a pharmacy question because instead of dealing with like pH and acids and bases, we're dealing with medicine. Okay, so this patient here, they need 20 micrograms per 1 hour. Now remember, I'm changing drops per minute. So I'm looking for drops per minute. You could change this to minutes. You could say 1 hour is 60 minutes and you'd get, micrograms per minute. That's easy. I usually do the minute thing at the very end, just because the first part is the most important. How do we get micrograms into drops? Well, I know that, let's do it this way first. First things first, I know that 0.5 liters of this solution would be 0.2 milligrams. Now, this doesn't really help me yet because notice nothing is canceling. I have micro and I have milligrams, so I can't cancel anything yet. So let's change this number here into micrograms. How do we do that? What's our conversion factor? Well, I told you over here that 1 milligram of anything is equal to 1,000 micrograms. Where did that come from? You have to remember, and don't worry, this information, what I'm about to show you will be given on a test or an assignment. You have to remember that you are expected to convert from, liters to milliliters or meters to kilometers. I guess not really for pharmacy, but you might have to convert from micro to milli. And to do that, a long time ago, if I go here to show all news items, a long time ago, I shared with you this. Okay, so the difference between, excuse me. Yeah, I mean, I call my parents sometimes, but I haven't talked to anybody in like 10 days. It's weird to hear myself speak. But anyways, if you can see the screen and you can see my pen here, the difference between milli and micro is 1,000 or 10 to the power of 3. So you could, if you want, move your decimal places. Okay, but this is saying that 1 milligram is 1,000 times bigger than a microgram. So where did these 3 zeros come from? 1, 2, 3. Okay, 1 milligram is equal to 1,000 micrograms. Okay, that's where that number comes from. And you guys can do these conversions any way you want to. You can move decimals, you can, whatever, however you feel comfortable, but make sure you review this at some point. And of course, guys, this will be given to you. You do not need to memorize this. I think other semesters, students had to memorize this, but I don't think that's fair because you'll always have a way to do this, right? You can use your phones in real life, or on a test, you can use this graph. Okay, so let's go back. This is where this number comes from. So let's go back to my notes. Right here. Okay, so you'll notice here that nothing is canceling, but now what I can do is I can multiply this by 1 milligram is equal to 1,000 micrograms. And now look what's happening. The milligrams have changed to micrograms. My micrograms have canceled and changed into liters. And guys, now we're getting somewhere. So I've converted my micrograms into liters, and I know that I have 15 drops per milliliter. So I'm almost there. Again, we have a problem. I can't cancel milliliters and liters. They need to be the same unit. So I'm going to multiply this by the fact that I know there's 1,000 milliliters in 1 liter, right? This is a tough one, by the way. Okay. Milliliters are canceled. So guys, look at what's left. All I have left is drops per hour. And I have one, this is a tough one, by the way. I'll put a little sad face here because this is literally about as tough as they could be. I have one more step left. I need to convert that hours to minutes, and that's a very easy conversion. I know that 1 hour is 60 minutes. Oops, I always cancel the wrong thing. So my hours cancel, and I'm left with drops per minute. So my answer, when you multiply all of this out, you would get 12.5 or 13 drops per minute. So just a little reminder here. Let me pick a different color. What I did was I went from micrograms to milligrams to drops. And I went from, actually, sorry, I didn't do that. I went from micrograms to milligrams to milliliters or liters to milliliters to drops. Right? So that's why this took so many steps. First, I converted my micrograms to milligrams, then to liters, then to milliliters, then to drops. And then, of course, I just went from hours to minutes. So that's why it looked like so many steps. This would be a good one for an assignment, but for a test, I'd probably make it look a little bit more like question A. Because question B, well, I mean, there's nothing wrong with question B. It's just a lot of work, a lot of conversions. So in this top one up here, I went from micrograms to milliliters to drops. And then I went from hours to minutes. This one was a lot easier. I encourage you guys to give this a little practice. Like there's question C here, and then even before question C, I don't think we did all of these. There's a lot more practice you guys could try to do, but I'll leave it at that for you guys to practice. Okay. So that's it for that. Let's get into the last part, the finale of chapter 2, compounding. I was thinking over the break, I was like, maybe I'll give them the assignment over the break, but then I figured if they might have needed a review for this, and I didn't want to give you extra work over the break besides maybe reviewing. Hopefully some of you maybe had some time to review some math. So let's look at the last part of chapter 2. And very shortly after this class today, I'll have the assignment number 2 up. It will be on just unit 2. So you'll have kind of a question from each section. And this will be one of them, compounding. This is, I think, my favorite part of this whole chapter. And you'll see why in a minute. It's basically like how I, or most people, would convert an entire recipe. So imagine you're making a recipe. And it's not Ramadan now, so I can easily talk about food. You're making cookies or you're making anything. And the recipe says, this will serve 4 people, but you need the recipe to serve 8. How do you convert all of the ingredients? Or maybe the best example is you see a recipe where it makes 2 dozen cookies, so 24 cookies, but maybe you only need 6. So how do you convert the flour, the sugar, the eggs, the baking soda, or whatever, baking powder? How do you convert all of those ingredients when you're scaling a recipe? And this is what compounding is. So it says here at the top, most preparations, so like making ointments or syrups or suspensions. Not sure if you guys can remember suspensions. I don't even know if we talked about that in chemistry too much, but a suspension is what we would call a colloid. It's when you have one thing dispersed or spread through something else. So, an example of a suspension would be a glass of Pepsi or Coke. You have in that suspended throughout the solution carbon dioxide gas in the liquid solution. A medical suspension would probably be liquid in liquid or solid in liquid. Like an aerosol would be a form of suspension, but I guess in pharmacy it might be, medicine, whether it's a solid or liquid, suspended, kind of mixed through another liquid. Anyways, ointment, syrup, suspensions, like anything made in a pharmacy are usually made with formulas or recipes. In chemistry, we would say formula. In cooking, we would say a recipe. And really the difference between this topic, making something like an ointment or syrup, and cooking a cake, there's really not much difference. The formulas list the amount of each ingredient that you need to make a certain amount of the preparation. It's literally like a recipe. So if any of you guys have ever in your life at some point cooked and followed a recipe, this is what it is. 2 cups of flour, 1 cup of sugar, 1 egg, that's a recipe. This is the same thing. However, you might need to alter the formula to make a smaller or larger amount of this. So you can do this using proportions or a conversion factor. And again, if any of you here like to cook or bake, this is exactly how you change a recipe. So if you ever see something that you want to, double, or you want to half it, this is what we do. So this is easier than it looks. I'm going to show you 2 ways. I think part B might be the easiest way for everybody, but I'll show you both and you guys can kind of pick whatever you like. Part B is definitely a lot less work, or not part B, sorry, method B. So there are 2 ways to do this, A or B. So let's look at proportions. which is a fancy way of saying ratios. So example number 16. The formula shown below is for making 1,000 milliliters of peppermint spirit. So peppermint spirit I doubt people use this much anymore, but it might be something you could use to like for congestion or to maybe soothe a sore throat. Again, I don't know. This is like peppermint spirit is probably like medicine from like your parents might have seen it like from 1950s or something. When I think of peppermint or menthol or anything like that, I always think of Vicks Vapor Rub. I don't know if you guys have ever used that, but peppermint scent or flavoring can typically help with congestion and things like that. It doesn't matter. So the formula, the recipe for this medicine is for peppermint spirit is peppermint oil. You need 100 milliliters of peppermint oil and 10 grams of peppermint powder, and you mix it with, and this is an interesting word, I guess not an acronym, but words here. You mix it with alcohol and then QSAD. So what is QSAD? Well, I had to look it up because it's anything like that, like typically in math or pharmacy or, any grouping of letters like this is typically from Latin. And I certainly don't remember any Latin. So QSAD stands for quantum sufficient. I'm not saying that right. It's like sufficient add, quantum sufficient add. This means as much as sufficient. Bleh. So when you see QSAD, what it means is you add as much to make the final total of 1,000 milliliters. So QSAD means to add, in this situation, means to add enough of this liquid, this alcohol, to the other ingredients to make up the 1,000 milliliters. So this is interesting. You're not going to see this a whole bunch from me, but you might see this in really old type of recipes. What this means is if I want to make 1,000 milliliters of this, I mix these two chemicals together. So you put them in a jar, and then you'd add the alcohol until you get 1,000 milliliters. So it doesn't actually tell you an amount. It just says, mix 100 milliliters of oil with 10 grams of pepper, or powder, not pepper, peppermint powder, and then add enough liquid here to make the final amount. So QSAD, Latin, quantum sufficient add, which means as much as sufficient or as much as needed. Interesting where it comes from, but anyways, all right, sorry. I didn't like a lot of these, like when you finish a math proof in math, you sometimes would say QED, and all these little things typically come from Latin when you see them. But anyways, that has nothing, you guys don't need to remember what that means. So how much of each ingredient is needed to do this? Oh, sorry, to make 240 milliliters. So I want to convert this recipe. I don't need 1,000 milliliters of this chemical, right? 1,000 milliliters, that's a liter. What if I only want to make 240, right? I just need about a cup of this to help a patient for a couple days. So how do I convert this recipe to make it smaller? Oh, and somebody in the chat just, it was a private message, but in chemistry, yeah, this is very similar to making a solution. So if you guys can remember chemistry 1120 or 1200, I don't know, they've changed the chemistry courses so many times now, but your first chemistry course, when you were in the lab, and you put some chemicals in what we would call a volumetric flask, but it could be a beaker. And then, so if you remember this device, right? And you put your chemicals in the bottom, and then you had a line there. And the line, in this case would be like 500 milliliters or something. This is like when you add water to get to this level. That's basically exactly right. All right. So, but you don't have to remember, this is not chemistry. So you don't have to think about chemistry here. We're just trying to convert this recipe. Okay, so I want to make 240 milliliters of this. I need to convert the entire recipe. Okay, so think about this recipe. All of this is per one. Well, I guess I shouldn't say all of this, because really we're adding the alcohol to make up the final amount. All of this is per 1,000 milliliters. Okay, so my ratio for peppermint oil, I know that, excuse me, I need 100 milliliters of peppermint oil if I have 1,000 milliliters. The question is, how much peppermint oil do I need if I only have 240 milliliters? I don't know if you guys remember doing this. I guess it was 3 weeks ago now. I mean, I wish I could say we did this last week, but Eid really kind of changed how this semester works. But, you know, it's 100 milliliters in 1,000. And I want to know, how much do I need for 240? This is the proportion method. So I would cross multiply here, and you would figure out that X is just 24 milliliters. I think if you don't understand this or don't like this, I think you'll like the other method better. So just hang on with me for a minute. Okay, peppermint powder. Well, peppermint powder is 10 grams per 1,000 milliliters. Okay, so 10 grams of peppermint powder would be in 1,000 milliliters. I want to figure out how many grams would there be in 240 milliliters. Okay, so again, you would solve for X, and you would get here 2.4 grams. All right, and then it says alcohol, QSAD, add enough so you have 240 mils of solution. Well, this is actually already done. I can't, there's no calculation here. Why isn't there any calculation? Well, I don't know. I can't tell you. Like, some of you guys might say, oh, well, why don't we just take 240, subtract 24, and the remaining is the answer. But remember, this is a volume, and the grams of peppermint powder might take up, it obviously takes up space. So when you see QSAD, there is no calculation. There's no way we can know with the information I've given you, there's no way we can know exactly how much we need to add, because I don't know how much volume these two numbers mix together. So if you were giving somebody this recipe and you were converting it, you would say, okay, you would take 24 milliliters of peppermint oil, 2.4 grams of peppermint powder, mix them together, and then add enough alcohol to have 240 milliliters of solution. And again, there's no calculation for that. There's no number, because I don't know what the answer will be. It will definitely be around 216 milliliters, right? 240 minus 24, but not exactly, because that 2.4 grams of powder will also take up space. So that's it. That's your recipe. It's kind of like, if you, again, I watch a lot of cooking on YouTube, and it's kind of like when they say add salt and pepper to taste. It's kind of like that. You'll notice most recipes, or a lot of them, don't tell you how much salt to add. It's like, oh, add it to taste. This is kind of the same thing, but we're not really adding to taste. We're just saying, mix it till you get to 240 milliliters. The alcohol here isn't the medicine, by the way. And if I don't know how far you guys went in chemistry, but it would be called a solvent. So the peppermint oil probably wouldn't mix very well with water, because oil and water don't mix. I don't know why it would mix in alcohol either. But anyways, typically in medicines, alcohols can be used as a solvent to help get things to dissolve. But that's chemistry, not this, so you don't have to worry about it. Okay, so you could do this. For every question, you could do this ratio over and over. But an easier way, this is how I do it with recipes. Like I have a book in front of me, like just a notepad where I do this all the time because I usually only cook like for myself, or I might cook a meal or a dessert for like, let's say 2 people because I'm only one person. So when I make cookies, I don't need to make 24. I might only need 6. So how do I change this recipe? Well, I don't go through every ingredient and do a proportion. I figure out, what is this recipe being converted by? Is the recipe being doubled? Is it being halved? Maybe I'm only making a third of the recipe. Then every ingredient gets multiplied by that. So the easiest example is if you had a recipe that made 12 cookies and you wanted 24 cookies, how do you do that conversion? Well, I know that 12 times 2 is 24. Sorry, this word is cookies. Well, to double the recipe, I double all the ingredients. So you double the flour, the sugar, the eggs. That's really, really easy. The only challenge here is sometimes you're not going to get a nice, pretty number. Maybe the recipe needs to be multiplied by 2.2. Maybe the recipe needs to be divided or reduced by 1.5. Like you'll see. So the other way to do this is to create what's called a conversion factor. Figure out how you're converting the recipe and then multiply. Yes? Yes?
You didn't do alcohol.
What?
You didn't do alcohol, QSAD.
Yep, there is no calculation. This is the answer.
Okay, mister, I get in peppermint powder 240.
Did you do this right here, what I'm circling?
Yeah.
Okay, okay, just hold on. Okay, let me do it over on the side here. So what you do with this question is you cross multiply. So you would get 10 times 240 equals x times 1,000. So that means x would be 10 times 240 divided by 1,000, which should be 2.4. Okay, so that all we did there is cross multiply. All right, I hope that helps. All right, if you have any more questions, let me know. And just, yeah, that was a good question too. So the student just said, your name didn't come up, but I didn't do the alcohol part. Well, I did. The answer's here. You just add enough to finish off the solution. Okay, so how do we do this without using those ratios? What if we were just going to use a conversion factor? Well, the conversion factor, this seems like a formula you'd have to memorize, but it's really not a challenging formula. You take what you're looking for. It's like in chemistry, depending on who your teacher was. It's you take the chemical you want and divide it by the chemical you have, or the quantity desired, what you're looking for, divided by the total amount in the recipe. So in the previous example, I wanted 240 milliliters, but the quantity of the recipe, the formula, was 1,000 milliliters. So my conversion factor is 0.24. I only need 24% or 0.24 of this entire recipe. So now all I do is you multiply each of these by your conversion factor and you're done. That's it. So I multiply all these things and you'll see me, I'm going to obviously do another example here, but I need 24 milliliters, 2.4 grams, and then the alcohol you don't worry about, you add until 240 milliliters. I think for me, like when I wish, I don't know. Hold on, let me just see something. Just take 1 second here. I'm just saying, like, I literally have a book in front of me of like I bring it into my kitchen when I change a recipe. And it's amazing how much this math gets used when I'm converting the recipe. Let me just see here. If I have I don't really have anything. My writing is a bit more of like, it's very much messy. So like, I don't know if you guys can see me, but like, so this is a recipe for like a salad dressing. You guys can't read the words, but the green in the recipe over here is the actual recipe. And the blue, this is really hard to do. It's like backwards on my camera. The blue is all the numbers converted. So the green is the recipe. It's backwards for me. And the blue is the conversion. So where did I get all those numbers for this? I just found out, how much am I reducing the recipe? Actually, the recipe right here, you can see I reduced it by 1/3. So every number gets multiplied by 0.333. And that's what I did in this book. So, this is something that if you could like to cook, you would use all the time. So let me show you one. I'll turn the camera off now. My hair is a bit crazy. I don't think you guys are like the first people who have seen me, except for the guy at the corner store or the little, the mini mart, in like 10 days. But let me show you how this one works. It's so much easier than it sounds. Okay. Oh, and here we go. Here's kind of a recipe. Actually, an interesting fact, and I think this is true. This is a question about making cola syrups. So fountain drink, like the drink that the Coke or Pepsi or whatever you would get at, say, like KFC or McDonald's, is made using a syrup of cola with carbonated water. So if you've ever watched them, or if you ever poured out your own drinks, back in Canada, they typically let you had to make your own drink. So what I mean is you just like kind of you control the machine. I don't know why. It's just a thing in Canada and the United States. You can get free refills, which is cool. But when you see it pour out, it's a mixture of water and syrup. And a lot of these things, like fizzy drinks, like carbonated drinks, so like Dr. Pepper, which is one of my favorites, Pepsi or Coca-Cola, many of these were created by pharmacists or chemists, they would call them, medical people creating, drugs or pharmaceuticals. Also invented a lot of things that we drink every day, like Pepsi, Coke, Dr. Pepper is another example. They thought back when they were invented, some of these syrups or sodas were medicinal. Not so much the case, but a lot of things that we take for granted every day, like Coke and Pepsis and sodas, and even like different candies and things, were actually created by pharmacists back before we understood a lot about medicine. So this says, use the official formula below to calculate how much each ingredient will be needed to make 120 milliliters of Coca-Cola syrup. Now look at, this is a good one. There's tons of stuff in here. So cola syrup, I don't know if this is the actual ingredients, but I guarantee a lot of this is true. Well, I don't know about the first part, but anyways, the ingredients are coca, or I guess coca powder. I don't know if that's spelled right. There's 180 grams. Sucrose, so sugar. Liquid glucose, so more sugar. Glycerin, this is probably used to give it some sort of thickness, I would guess. Sodium chloride, salt, vanillin for vanilla flavor, and sodium benzoate. I don't know what that would be for, but these are all my ingredients. And all of these ingredients will be mixed with water to make 1,000 milliliters. So this is really important at the end. This tells me how much this recipe will make. So I'm going to add, this is a different formula or recipe than, say, something you get on the internet for cookies. But if I was going to explain this recipe to you, take 180 grams of cocoa or coca, whatever that is, 600 grams of sucrose, 180 milliliters of liquid glucose, 50 milliliters of glycerin, 2 grams of sodium chloride, 0.2 grams of vanillin, 1 gram of sodium benzoate, and then add water to make 1,000 milliliters. Now, I only want to make, I'm just going to zoom out here. I only want to make 120. So what would my conversion factor be? Well, I'm looking for 120. The recipe makes 1,000. My conversion factor would be 0.12. I only need 0.12 of this recipe, or I guess if we converted this into a fraction, sorry, we would get, oh, I thought it'd be a better fraction than that, 3/25. But okay, let's avoid fractions. Let's just use decimals. I only want 0.12 of this recipe. So what I'm going to do, and I do see something in the chat there. Here, let me do this so we can keep my number there. What I'm going to do is multiply every number here by 0.12. And again, guys, you could do this with a recipe for anything. Sorry, I won't do that. I'll just cross that out. You could do this with anything. The only problem I find with baking or cooking is you get in trouble with an egg, right? How do you use like 0.12 of an egg? I mean, what you could do is mix up the egg and then weigh it. But I mean, that's just most recipes. I would try to use the egg to control how much of the chemical I need, other chemicals. So somebody in the chat there, Dominique, I'll say your name because you got it right, just wrote me a private message. The conversion factor is 0.12. So that's it. Multiply all these things by 0.12. So this would be 21.6 grams, 72 grams, 21.6 milliliters. Maybe I'll zoom in so I can write a little easier. And there we go. 6 milliliters, 0.24 grams, 0.024 grams, and 0.12 grams. And then QSAD to 120 milliliters. Again, what this means is we're going to add water. Let me zoom back out. We're going to add water until this equals 120 milliliters. All right, there you go. That's pretty easy. I encourage you guys to this week maybe bake something, try a recipe and see if you can change the amount. Okay. I'm pretty much, we're done. Like, look, there's nothing left of this chapter. I'm certainly not going to start chapter 3 today. How about I just do one more and then I'll get you guys to practice and then that's it. Okay, I'll do one more. Why not? We're going pretty quick today. Okay, so did I skip anything? No. Use the formula listed below to find the amount of each ingredient needed to make 1 pound of baby powder. Okay, boric acid and baby powder, maybe. So again, I don't know if any of these are real. I know what 2 of these ingredients are. I don't know what you would use zinc stearate for, but I do know boric acid is in a lot of contact solutions. So if any of you are contact lenses, boric acid is typically in there, kind of like as a cleanser. Talcum powder would be like your drying agent. So anyways, here we go. I want to make 1 pound of baby powder. Now, this one, I'm glad I'm doing this one for you. This has a little bit of work involved because I can't really easily calculate my conversion factor here. There's a little bit of information I need to do first. First of all, how much of this baby powder am I actually making? Like, this is a recipe. I want to make 1 pound of this powder. I'm going to zoom out 1 block here. There we go. But how much does the recipe actually make, right? How much is this recipe? Well, if I add up all of these numbers, I'm just going to add up 30 and 20 and 50. This recipe makes 100 grams of baby powder. Now you'll notice there's no QSAD in this one. These are just this is just 3 solids mixed together. So having a recipe for 100 grams. How do I make a pound? Well, I got another problem. How many pounds do I actually need here? Right? That's a question. So first things first, I need to find out what is 1 pound into grams. So I need to use a conversion factor for that. Now remember, any of like please remember this, because I remember before EAT, I had a student kind of like, where are you getting these numbers? Any of these conversions, so metric like milliliters to microliters, or anything like that will be given. You will also be given conversion from pounds to grams. Okay, and 1 pound is equal. Actually, I guess I don't need to do this. 1 pound is equal to 454 grams. This will be given to you. Okay, so if you need to convert from centimeters to inches, grams to pounds, it will be given to you. This is the only reason this one's so easy is because we're just dealing with 1 pound. All right, let me just check the chat before I finish this. Kalsum, thank you. Perfect. Kalsum in the chat knew this already. I actually had to look that up. I know how many, what was it? I know how many kilometers are in a mile or miles are in a kilometer. I have that one memorized from driving in the US a lot, but pounds and grams, I don't know as much. But there you go. 1 pound is equal to 454 grams. Or actually, what you guys would probably get, to be honest, let me just go back here. What you guys would likely be given on a test, and I'm going to kind of change how this one's done. What you would probably be given on a test is that 1 kilogram is equal to 2.2 pounds. So if you were trying to figure out how many grams was 1 pound, what you would do is you would multiply this by 1 kilogram over 2.2 pounds, and then you would multiply this by 1,000 grams over 1 kilogram. This is probably what you would have to do on a test, because this is typically the conversion factor that you would be given. So 1 divided by 2.2 times 1,000 gives me 454, about 454 grams. About, right? You could say 455, 454. This is just a rough calculation because there is no nice, easy way to convert from pounds to grams because imperial unit is crazy. I have a private message here. It says, why did I choose 1 pound? It's in the question. It says, use the formula listed below to find the amount of each ingredient needed to make 1 pound of baby powder. So if anybody's wondering why I picked 1 pound, it's because that's what the question's looking for. Okay, so now I'm going to come up with my conversion factor. I need 454 grams. My recipe makes 100. Oops. My conversion factor would be 4.54. So every one of these numbers gets multiplied by 4.54. And that's it. So remember, this is a recipe. My recipe tells me how to make 100 grams. I want to make 454 grams. So I do my conversion factor here to tell me that every ingredient must be increased or multiplied by 4.54. Okay, so my answer, let me pick a different color here. Sorry, I'm just going to go with a red here. I'm going to delete all that. I'm going to change my color to red. Okay, so everything here gets multiplied by 4.54. So I end up with 136.2, 90.8, and 227 grams. And these added together should be 454. There we go. So I have another question in the chat. Why do we divide 454 by 100? This right here. This is so we can figure out how to convert our recipe. The conversion factor, the form, like it's not really a formula. I hate showing this formula because it's not really a formula, but it's the amount that you're looking for over what was in the formula or what was in your recipe. So the conversion factor is the amount that we're looking to make divided by the amount in the recipe. So why did I divide 454 by 100? Well, 454 is the amount I'm trying to make. The recipe is 100 grams. So basically, I'm trying to increase the original recipe by 4.5. That's why I divided that. Does that make sense? Okay, no comment. I hope that makes sense. I didn't mean to go this long, by the way. Hold on one second. The total amount is given. The total amount, okay, so sorry. Let me make sure I'm recording. The total amount is given. 30 grams, 20 grams, and 50 grams. The total amount is 100 grams. This recipe makes 100 grams. Right? If I add up all the masses of these things together, this recipe makes 100 grams. All right, perfect. Might take a bit of practice to figure this out. Okay, so sorry. One thing I was just going to mention, I was hoping to be finished like right now at 10:15, because this is a pretty quick and easy course. We will never need the full 2 hours. Most days will only need an hour, maybe an hour and 15 minutes. However, I'm just like I'm only maybe 2 or 3 minutes behind where I wanted to be, because before you guys leave me, I would love for you to just try one and we can look at the answer together. Now, one thing before you do practice question 8. I'm paranoid I'm not recording. You need to be able to convert from ounces to grams. Okay, so let me do that for you. 1 ounce. So before you start, 1 ounce is equal to about 28 grams. It's actually 28.3, but we'll keep it like that. Should I keep it like that? Yeah. Yeah, let's keep it like that. 1 ounce is equal to 28 grams. Okay, so I'll give you guys a couple of minutes to try this one. Just trying to think of how I would give this to you on a test. Yeah. Hold on one second. If you were given this on a test, the information you would have is to do this conversion factor, you would have, or you would know that 1 kilogram is equal to 2.2 pounds. You would also know that 16 ounces is equal to 1 pound. Okay. And you would probably also know, like I just said, 1 ounce is 28 grams. All this information would be given to you. You do not need to memorize imperial to metric conversions. So I'm just trying to give you some information here. You don't need all of this information. For this one, you only need ounces to grams. But yeah, good luck. I want you to figure out how to make 10 ounces of pine tar ointment, and this is the recipe for pine tar. Yellow wax, yellow ointment, and pine tar, whatever these are, you need to mix them together, and I want you to make me 10 ounces of this. So I'll be back in 2 minutes and we'll check your answers. All right, I'm getting tons of answers in the chat here, which is awesome. Keep going, keep working away. I think it's Loa. I can't see your full name. Yes, it is Loa. Loa's doing like the like kind of like the with the decimal place conversion. This was a private message, by the way, so you guys probably can't see this, but Loa, you're doing a very good conversion there for how many grams. We're going to round ours a little bit, but yes, that's a perfect answer. Okay, cool. Just one more minute. I think most of you guys are getting this. One more minute, and then we will look at the answer. All right, so let's have a look at this one. Oops. Clear this. Okay. So we can do another one of these tomorrow. Like maybe tomorrow's class we'll kind of do number 9 to make sure everybody's okay. But let's look at this right now. So use the formula listed below to find the amount of each ingredient needed to make 10 ounces. Well, first things first, I need to figure out how many grams that's actually going to be. Now my grams, like some of your answers might be off by a decimal place or two, but it really doesn't matter, because when you're converting from ounces to grams, you're getting you're rounding the number anyways. So the first thing I'm going to do is I'm going to figure out how much of this recipe we actually need. Sorry, not how much we need. How much does this recipe actually make? And this recipe will make 100 grams of this ointment. So what I need to figure out is how many grams excuse me, I got the hiccups, is 10 ounces. And then convert that or find the conversion factor. So 10 ounces is approximately, I know that there's 28 grams in 1 ounce. So it's approximately 280 grams. Some of you guys did the conversion factor using 454 grams per pound. That's fine. You got 283.7. It's pretty much, you know, like it's never going to be perfect when you're converting from metric into imperial. So it's around, that's what these squiggly arrows mean here, or squiggly equations, 280 grams. So what's my conversion factor? Well, I'm looking to make 280 grams, but the recipe has 1,000 grams. So my conversion factor is about 0.28. Now, some of you might have had 0.283. That's fine. I'm keeping mine rounded nice and small, but if you had 0.283, totally fine. So I'm going to multiply everything here by 0.28. Okay. And again, this is going to give me some pretty rounded answers. I like to keep these a bit rounded if I can. So this is about 42 grams. If you had 42.5, that's perfect. 350 times 0.28. This would be about 98 grams. Again, if you had 99, that's fine. And then 500 times 0.28 would be around 140. Again, if you had 141 or 142, that's fine. This is approximate because, again, converting from ounces to grams isn't perfect. So if you had anything near this, you might have 43, 99, 141, 43, 99, 142. That's perfect. I'm not looking for exact numbers here. And again, that happens anytime you change from the metric unit of grams to something imperial like ounces. It doesn't really convert very pretty. All right, guys, perfect. That's it for me. That's it for today. Now, I am going to put up your assignment. You just give me a little bit of time to finish this, like get the recording up, and I'll put your assignment up. The assignment won't be due until Sunday, but we do have to have your second test next week, or sorry, your first test next week, not your second test. Don't worry. Does anybody have a day that works or that doesn't work for them? The best days for this test would be probably Wednesday or Thursday next week. Does anybody have a preferred day to do this test? Wednesday or Thursday? I'd like to give you a week to study. We could do it on Monday, but that's a bit too soon. Anybody in the chat have a preferred day next week's? Could be Wednesday, could be Thursday. What do you guys think? I wouldn't pick Tuesday because Tuesday you have class at 7:30 and that's way too early. It's okay. So yeah, I guess one thing I should mention. So Asma, you're having a midterm. Some of you are having a midterm on Tuesday. So don't worry, the test will be after Tuesday. You guys have test on Tuesday, so it won't be Tuesday. Don't worry. I will warn you though that it is not online. There's only 15 students, so we can socially distance. I can book a lecture theater, meaning we can have the whole theater to ourselves to socially distance. It's not online, but would Thursday be better if you have a midterm on Tuesday? Is Thursday good? That'll give you a week and 1 day to do this. Okay, perfect. So guys, I'll make a posting about this online, but let's have our first test. It'll be on chapters 1 and 2 on Thursday. I can't do Sunday, that's too far, but I can definitely do Thursday. It'll be super easy. I'll give you lots of review, and it'll be a week from tomorrow. So Thursday, it will be on campus. But I'll give you more information about that once I book a room. All right, it'll be on so chapters 1 and 2 only. So this is it. This is the end. This is it. That's it. Halas for the test. Anything we do in chapter 3 or 4 is not on your test. And I'll do a review probably like, let's say Wednesday next week, we can do a little review as well. All right, cool guys. So take care. I'll have an assignment on chapter 2 up. You'll have a few days to do that. I'll give you until, Sunday at midnight to do that. Other than that, that's it for me. So I'll see you all tomorrow, and I can answer any questions that you have about the assignment or the test tomorrow morning. All right, take care, guys. Have a great day. Welcome back. Thanks. I hope you had a good break. I'll see you soon. Bye-bye.